Celery got attention. But async LLM workloads need their own queue pattern. Arc keeps the worker async instead of fighting the event loop. You'll learn the shape of a workflow that schedules language model jobs into a lightweight queue and drains them with bounded retries. I'm Professor Pi, teaching AI engineering and LLM systems with simple Python. LLM APIs are slow per call and easy to overwhelm. One request might take a second or two, but scale brings rate limits, timeouts, and surprising retries. The bottleneck isn't CPU. It's coordinating lots of I/O-bound calls without blocking the event loop or spawning heavy worker processes. That's exactly where Arc fits, a Redis-backed queue and workers that stay async, so you keep the same asyncio-friendly style you already use. The idea is straightforward. Treat each prompt as a job object you push to Redis. Let lightweight async workers pull jobs, run them with bounded retries, and respect concurrency caps. The payoff is predictable throughput, clear retry behavior, and the ability to inspect what's next when things go wrong. The trade-off is you need Redis and to tune max jobs and delays, but you avoid a heavyweight worker fleet. We'll build a compact pipeline. First, we time mock LLM calls for a baseline. Then, we enqueue prompts into Redis. Next, we register an async worker and inspect queue ordering. After that, we add a retry guard for noisy prompts. Finally, we run a worker in burst mode to drain the queue and inspect results. This sequence shows how to keep latency while adding reliability. Quick note, this code is designed to teach the core idea clearly. Library versions and local setups can vary, so check the official docs if your setup behaves differently. First, measure the plain asyncio baseline, so we know the latency budget the queue must preserve. This snippet measures asynchronous LLM mock latency to anchor our queue goals. The practical question is whether the queue preserves the raw async I/O latency. So we run 3 fake prompts through a mock LLM that simply awaits asleep. The prompts list feeds those phrases. Asyncio.gather launches them concurrently on the same loop, and perf counter times the run so we can compute per call averages. Because the fake LLM is just sleeping, the profile matches real LLM API I/O behavior without touching production. When AVG latency prints, we have the baseline batch time to target as we layer Arc on top. Now, we need to push those prompts into Redis in a non-blocking way and keep track of the job IDs for later checks. This example uses Arc's async Redis pool to enqueue our LLM prompts. The practical worry is how to push jobs without bringing in Celery's heavy worker stack. So creating a pool with your Redis settings keeps everything as a single lightweight asyncio client. The enqueue loop iterates over prompts, calls enqueue job with a shared job name that matches our future worker, and collects the return job handles for later inspection. By stashing enqueued IDs, we avoid extra Redis reads and keep the sequence deterministic for the monitoring steps ahead. The queued jobs print shows 3 async tasks ready to process, and a concrete job ID you can follow through retries and health checks. Next, we must register the async worker function and add an inspect path so we can see which prompt will run first under backlog. This code wraps the job with Arc's worker func and inspects queue ordering. The practical question operators ask is which prompt fires first when backlog builds. So func registers process summary with the queue name, timeout, and the retry ceiling Arc enforces. The worker context set default call shows how to stash per worker state without blocking, while awaiting the fake LLM keeps the coroutine strictly I/O bound. The inspect queue helper reopens the pool, fetches queued jobs, and sorts by enqueue time to surface the oldest prompt, giving you the visibility you'd want during an incident. When next prompt prints, you immediately see which payload will run next and how many remain, which helps you reprioritize before spinning up workers. Some prompts are noisy or hit rate limits. We should show a simple retry guard to defer a troublesome prompt before it consumes all retries. This snippet adds an arc retry guard to defer noisy prompts before they burn retries. The production concern is rate limiting, so guarded summary checks the summarize log prompt and raises retry with a 2-second defer on its first try. Arc injects context.job try, letting us branch without extra globals. And reassigning render summary keeps the same task name while bumping max tries to 4. The preview retry helper runs the coroutine directly, catching retry so you can validate the defer value without booting a worker or hitting the model endpoint. Seeing retry delay 2 confirms the guard will pause that prompt before the queue spends all its retries. Finally, run a controlled worker to drain the queue and verify completion and metadata. This example runs an arc worker in burst mode to finish the queue and read results. The ops question is whether arc drains cleanly under tight concurrency. So we run worker with burst equals true and max jobs equals 2 to mirror production caps. After async run returns, we reopen Redis and loop over the enqueued IDs, awaiting each job result to verify completion and collect metadata. A plain for loop keeps debugging straightforward, and the result timeout guards against a missing or stuck job. The completed jobs print shows 3 plus the final prompt, and proves the worker honored the concurrency cap while still draining everything. In a real project, you would graft these pieces into your request path. The timing baseline sets your SLAs. The enqueue step belongs in the API layer. The worker code becomes a deployable service, and the retry guard maps directly to rate limit strategies or back-off rules. Add monitoring for job age and try counts so incidents surface quickly. Recap: Arc async job queues keep workers asynchronous and Redis-backed so you preserve event loop performance while adding retries and visibility. Use this pattern when you need to coordinate many I/O-bound LLM calls with controlled concurrency. One caveat: tune Redis persistence and worker concurrency to match your rate limits. Next step: tune the worker concurrency and max tries for your traffic. Then measure end-to-end latency and job age under realistic load. If short, practical AI engineering helps, subscribe and watch the AI engineering videos.